Okay, so in part 3 of solving linear inequalities, we're going to continue discussing solving linear inequalities using the addition and multiplication properties of inequality. In number 1, you have the inequality 3x minus 7 is less than 6x plus 2. And if this was an equation versus an inequality, the procedure would be the same, except remember there's one part from a previous lesson you learned that if you multiply both sides or divide both sides of an inequality by a negative number, you have to reverse an equality symbol. So you learned that in a previous lesson. So what we're going to do here is we're going to bring the variables to the left-hand side. And so we're going to use the addition property of inequality to do this. So I'm going to subtract 6x from both sides. And then remember we're using inverse operations. And then I'm going to combine like terms. So 3x subtract 6x is a negative 3x. And then minus 7 is less than, and then 6x minus 6x is 0. 0 plus 2 is 2. All right, so then continue using the addition property of inequality. I'm going to add 7 to both sides. So what you do to one side, you do to the other, whether it's a inequality or an equation. And then we can combine like terms. So when I combine like terms, these are opposites, remember. So negative 7 plus 7 is 0. Negative 3x plus 0 is still negative 3x. It's less than. And then 7 plus 2 is 9. All right, and then we have to obtain x by itself. So remember, all these inequalities are equivalent. They're all equivalent. So solutions for this is the same as solutions for this, the same as solutions for this. But let's go one more step. So I've got to obtain the variable x by itself in order to really determine what the solutions are to the original inequality. So right now, the coefficient of x is negative 3, which means that you're multiplying x by negative 3. So I really want this to be a 1. So we're going to do the inverse operation. So the inverse operation of multiplication is division. So I'm going to divide both sides by negative 3. Now remember, one of your multiplication properties of inequality says, that if you multiply or divide both sides of an inequality by a negative number, which I am here, I've got to reverse this inequality symbol. So negative 3 divided by negative 3 is 1. 1 times x is x. But my solutions will be any real number that is greater than, and positive 9 divided by negative 3 is a negative 3. So any real number greater than negative 3. So the graph would look like this. So if this is 0 and this is negative 3, we're going to either have an open circle or parentheses. It doesn't matter which one you use. I'm going to go ahead and use an open circle in this case. And open circle, remember, because negative 3 is not a solution. Negative 3 is not bigger than negative 3. Negative 3 equals negative 3. So that's why we use an open circle. If there was an equal sign here, if this was greater than or equal to, then it would be a closed circle or a bracket. All right, so you can learn that in previous lessons. All right, so then I'm going to shade in the solutions. Remember, you're graphing the solution. There are an infinite number of solutions. Remember, this is saying all the solutions are any real number greater than negative 3. Well, there are an infinite number of real numbers greater than negative 3. So you can't list them. So we're going to graph them instead. So I want all the real numbers that are bigger than negative 3. So I'm going to go to the right. I'm going to shade the number line to the right. So, and don't forget the arrow. So any number greater than negative 3 is a solution. In terms of interval notation, remember open circle, negative 3 is not a solution, so use parentheses. Negative 3, comma, and then infinity, parentheses. And then if they ask you to write this as set notation, so set notation, you say the set of x's such that, and then this inequality symbol, this inequality notation right here, such that x is greater than negative 3. And then don't forget to close your set. All right, so that was number 1. Okay, now let's remember about this. So let's look at the same problem again. So I'm gonna put this as 1 star. And so we had 3x minus 7 is less than 6x plus 2. Now remember, what we did was we brought the variables to the left. But what if you had brought the variables to the right-hand side? So same thing, you subtract 3x from both sides in this case, and then combine like terms. So again, I was using the addition property of equality. 3x and a negative 3x is 0. 0 and negative 7 is negative 7. It's less than, and then 6x minus 3x is 3x plus 2. And then subtract 2 from both sides, again using the addition property of inequality, and then combine like terms. -7 and a -2 is a -9 is less than 3x, and then 2 and a -2 is 0. So just like we did here, I've got to get the variable x by itself. So the solutions to this will be the same as solutions to this and the solutions to this. And this is what I'm interested in. Find the solutions to this original inequality. So I'm going to go one more step. I'm going to get the variable x by itself. So I'm going to divide both sides by 3. Now remember, I'm dividing by positive numbers, so that's fine. I don't have to, I don't reverse an equality symbol. You only reverse an equality symbol when you divide or multiply by a negative number. So this is a positive number in this case. So -9 divided by 3 is a -3, is less than, and then 3 divided by 3 is 1, and then 1 times x is x. Now here's the difference. You have to be careful when you have with an inequality, you have the variable on the right-hand side. So what this is saying is that -3 is less than any of the other solutions. -3 is less than any real number that's a solution to this inequality. So that means -3 is the smallest possible solution. Now I say the word possible because there's no equal sign, so -3 is not really a solution. But -3 is going to be the smallest bounded number that you're going to put in the number line. In other words, if this is 0, this is -3, you're going to put an open circle just like you did here. But remember, this says that -3 is the smallest. So that means you're going to shade in everything to the right. -3 is the smallest. So you got to be careful because what some students do is they see this less than and automatically think less than, you go to the left. But you got to be careful because the variable is not on the left-hand side. The variable's on the right. So you have to be careful with inequalities where the variable's on the right-hand side. So basically, when we say that -3 is less than x, we're also saying this is equivalent to saying that x is greater than -3, which is what we had here. Okay, so just be careful when you have the variable on the right-hand side, so you don't draw the graph in the wrong direction. All right, so I wanted to make that point there. Okay, number 2. All right, number 2, suppose you had, all right, let's see. Suppose you had 4 times 3x minus 1 is less than or equal to 5 times 2x minus 4. Okay, so we're going to use distributive property, just like you did with the equations. And so 4 times 3x is 12x. 4 times a -1 is a -4. Is less than or equal to 5 times 2x is 10x. And then 5 times a -4 is a -20. All right, so I'm going to bring the variables to the left. With inequalities, it's usually best. You don't have to, just like we saw here. You can bring the variables to the left, or you can bring the variables to the right. But if you bring the variables to the right with an inequality, you got to be careful with your graph, with this interpretation. So I'm just going to go ahead and bring them to the left. All right, so I'm going to subtract 10x from both sides. And then, to remember, I just use the addition property of inequality. So then, combine like terms, 12x minus 10x is 2x. I get 2x minus 4 is less than or equal to 10x minus 10x is 0. 0 negative 20 is a -20. Adding 4 to both sides. And then combine like terms. I get 2x and 0 is 2x. Is less than or equal to, and then that will be a -16. And remember, I'm trying to find the solutions to this original inequality. All right, so all these are equivalent inequalities. That means is that all these inequalities here, the solutions are the same. So I'm almost to the point where I can determine very easily what the solutions are. So I got to get the variable x by itself. So right now I'm multiplying by 2. The inverse operation is to divide by 2. So I'm going to divide both sides by 2. And then 2 divided by 2 is 1. 1 times x is x. It's less than or equal to. And remember, the symbol stayed the same because I did not, in any situation here, I did not multiply or divide by a negative number. So I'm dividing by a +2. And -16 divided by 2 is a -8. So I found my solutions to the original inequality. In fact, all these inequalities, the solutions would be this. So any real number that's less than or equal to -8, including -8 because there's an equal sign. -8 is equal to -8. So the graph, if this is 0 and this is -8, I'm going to use a closed circle. And then I'm graphing all the real numbers that are less than or equal to that. So it's closed because negative 8 is a solution. There's an equal sign here. All right, integral notation. So remember, you read a graph from left to right. Your arrow's pointing to the left. So you're going to say from negative infinity to negative 8. Now remember, infinity and negative infinity always use parentheses, comma, and then negative 8. Since this is a closed circle, since I can include negative 8 as a solution, we're going to put a bracket. And then set notation. If they ask for set notation, you're going to say the set of, remember the brace, use a brace for set notation. The set of x's such that, it's got to look like this, set of x's such that, this means such that x is less than or equal to negative 8. And then don't forget to close the brace. All right, number 3. Number 3, suppose you had 3 times x plus 2 minus 6 is greater than negative 2 times x minus 3 plus 14. So 3 times x plus 2 minus 6 is greater than negative 2 times x minus 3 plus 14. All right, so just like you did in the previous lesson with equations, you would use the distributive property to get rid of the parentheses. So use the distributive property here and then here as well. So 3 times x is 3x, 3 times 2 is 6, and don't forget to bring down this subtract 6, is greater than. Negative 2 times x is negative 2x, negative 2 times a negative 3 is a positive 6, and then plus 14. All right, combining like terms, this right here is 0, positive 6 and negative 6 is 0, so all you're left with on this side is 3x is greater than. And then negative 2x, and then 6 and 14 is 20. All right, let's bring the variables to the left. So adding 2x to both sides, and then combine like terms, I get 5x is greater than, and then 20. And then, so I'm almost in the process of determining what the solutions are. So the solutions to this inequality is the same as solutions to this. They're all equivalent. So I just do one more step and then I can easily determine the solutions. So to get the variable x by itself, right now I'm multiplying by 5. That's your coefficient. You're multiplying by 5. So the opposite of multiplication is division. So I'm divide both sides by 5. Now remember, I'm dividing by positive numbers, so this stays greater than. 5 divided by 5 is 1. 1 times x is x. So all the solutions be any real number that's greater than 20 divided by 5 is 4. All right, so all my solutions are going to be any real number bigger than 4. So the graph, if this is 0 and this is 4, you put either parentheses or open circle. I'm going to use parentheses this time. So I'm going to put parentheses and it's going to the right. So parentheses just like this, make it look like parentheses, and then going to the right. And make sure the parentheses is on the 4. Don't draw it in front or in back. It's got to be on the 4. All right, and then interval notation, so you read a graph from left to right. So I'll start at 4, parentheses, comma, infinity, parentheses. And then if they ask you for set notation, you're going to say the set of x's such that x is greater than 4. Number 4, suppose we had this problem. All right, suppose we had negative 5 times 1 minus x plus x is less than or equal to, and then we have this, the opposite of, or negative of 6 minus 2x, and then plus 6. All right, so we're going to use distributive property first. This part's easy because negative 5 times 1 is a negative 5. Negative 5 times a negative x is a positive 5x, and then plus x is less than or equal to. Now remember, if there's no number right there, it's understood to be a 1. In this case, it's a negative 1. So you distribute the negative 1. Or you can also think of this as meaning the opposite of 6 minus 2x. So a negative 1 times 6 is a negative 6. A negative 1 times a negative 2x is a positive 2x. And then plus 6. All right. Now, combine like terms. 5x and x is 6x. I get 6x minus 5 is less than or equal to, now a negative 6 and a positive 6 is 0. So I'm left with 2x. All right, so that's where I'm at. All right, now, it does not matter which side you bring the variables on. If this was an equation, probably you would bring the variables to the right-hand side. This was an equation. But since it's an inequality, since we know that for the most part, some students mess up when they bring the variable on the right-hand side with an inequality. Because if it's on the right-hand side, you really need to be careful that you don't draw the graph going the wrong direction. So let's just bring the variables to the left like we were doing. So I'm going to subtract 2x from both sides. And so 6x minus 2x is 4x minus 5 is less than or equal to, and then 2x minus 2x is 0. So I got to put a 0 here though. Then adding 5 to both sides, and then combining like terms, I get 4x is less than or equal to 5. So 4x is less than or equal to 5. All right, so then dividing both sides by 4. And then 4 divided by 4 is 1. 1 times x is x. So I get x is less than or equal to 5/4. Okay, now the graph, if this is 0, this is 1, this is 2. 5/4, if you use your calculator, 5/4 is 1.2. So 1.25. So 5 divided by 4 is 1.25. All right, so that's close to 1. All right, so let's say it's here. So this is 5/4 right here. So let's put 5/4 right here. All right, since 5/4 is a solution because there's an equal sign, I'm going to use a bracket. Let's use a bracket this time. And then I want all the real numbers that are less than or equal to 5/4. So it's going to be a bracket pointing to the left, just like this. And then shade in all the real numbers that are less than that. But don't forget the arrow. So interval notation, since the arrow is pointing to the left, you're going to say negative infinity with parentheses, comma, all the way to 5/4 with a bracket. Bracket because there's an equal sign here. If you put a closed circle, you could put a closed circle or bracket here, does not matter. Set notation, you'd say the set of x's such that, and then just write your solution such that x is less than or equal to 5/4. All right, now, if you had, see right here where we brought the variables to the left? Let me just show you something. If you had, and it doesn't matter, but if you had done this, let me write this step right here over. If you had done this, let's say you brought the variables to the right-hand side. So you said subtract 6x from both sides. So you can do the inverse operation and then combine like terms. Remember, that's a 0. That's what you wanted. So you get negative 5 is less than or equal to, and then 2x minus 6x is a negative 4x. Okay, now we got to get the variable x by itself. So I'm going to divide both sides by negative 4. Now remember, I'm dividing by a negative number, so I've got to reverse this inequality symbol. So you got to always remember that. A negative 5 divided by negative 4, a negative divided by negative is a positive, so negative 5 divided by negative 4 is a positive 5/4. You got to make sure you write it as positive 5/4 and not negative divided by negative. Is greater than or equal to, and then negative 4 divided by negative 4 is 1. 1 times x is x. All right, now you got to be careful because the variable's on the right-hand side. So if this is a 0, and this is 1, and this is 2, remember this is 5/4 right here. And we're going to use let's just use a closed circle this time. Just to vary what we're doing. So we use brackets here, let's use a closed circle this time. All right, so we use a closed circle. And then the question is, which side do I shade in? All right, so remember this says that negative 5/4 is going to be bigger than any solution, than any of your other solutions. So negative 5/4 is the biggest, is the largest solution. So that means I got to shade in all the numbers to the left. So you got to be careful because some students, when they do this, when they put the variable on the right-hand side, they kind of mess up because they see the word greater than or equal to and they want to go to the right. So you got to be careful. So 5/4 is bigger than or equal to, is greater than or equal to x is the same thing as saying x is less than or equal to 5/4. And so then you would shade everything to the left. All right, so just be careful when you bring variables to the right-hand side with inequalities. Okay, number 6. Suppose in number 6 you had this. Number 6. Suppose you had negative 5x plus 4 is less than or equal to negative 4 times x minus 1. All right, so I use the distributive property. So I get negative 5x plus 4 is less than or equal to, and then negative 4 times x is negative 4x. Negative 4 times a negative 1 is a positive 4. All right, let's bring the variables to the left. So I'm going to add 4x to both sides using the addition property of inequality. Combine like terms. A negative 5x and a positive 4x is a negative x. Plus 4 is less than or equal to, combine like terms here, 0 plus 4 is 4. All right, now subtracting 4 from both sides, and then combine like terms, I get negative x, see this is 0 here, negative 4 and a positive 4 is 0. So I get negative x, but I'm going to go ahead and write it as negative 1x. It's less than or equal to, and this is 0 as well, so you don't forget to put that 0 there. All right, now you got to be careful. I need to get x by itself. This is a negative 1x, so I need this to be a positive 1. So right now, multiplying x by negative 1, the opposite of multiplying by negative 1 is to divide by negative 1. So notice I'm dividing both sides by a negative number. So whenever you multiply both sides or divide both sides of an inequality by a negative number, you've got to reverse this. So negative 1 divided by negative 1 is 1. 1 times x is x. So the solutions would be any real number that's greater than or equal to, and then 0 divided by negative 1 is 0. So you have to say 0. So those are your solutions. Any real number bigger than or equal to 0. So the graph's going to look like this. If this is 0, close circle because of the equal sign, and then going to the right. Your interval notation, you'd say bracket, 0, comma, infinity. And then set notation, you'd say the set of x's such that x is greater than or equal to 0. All right. Number 7. Number 7, suppose we had 1/4 times x plus 4 is less than 1/5 times 2x plus 3. All right, so this time we have fractions. Now, when we did the equations from a previous lesson, remember what we did first was we distributed first. All right, so we distributed. So we said 1/4 times x is 1/4 x plus, and then 1/4 times a positive 4 is 1, is less than 1/4 times 2x. Now remember, I'm sorry, 1/5. 1/5 times 2, remember that's 2 over 1, is 2/5. So 1/5 times 2x is 2/5 x. 1/5 times 3, 1/5 times 3, and that's 3 over 1, is 3/5. So 1/5 times a positive 3 is a positive 3/5. Okay. Now, what we did, remember, was we had to clear the fractions. So we're going to clear the fractions by finding the LCD. So we're going to multiply both sides by the LCD. So the LCD here, this denominator is 4. This denominator here is 1, 1 over 1. So that's a 1. 5. So the LCD is 20. All right, so we're going to multiply both sides by 20 to clear the denominators. Clear the fractions. So I'm going to enclose both of those in parentheses, just like we did when we had equations, just like this. And then I'm going to say times 20 times 20. All right. Then I'm going to distribute the 20 again. I'm going to use the distributive property again. So 20, remember the whole purpose of multiplying by the LCD is to reduce these denominators. So in other words, I'm going to end up having ones here. This will be a 1, this will be a 1, this will be a 1. But you have to distribute first. Don't make the mistake and reduce and say 4 into 4 is 1, 4 into 5 is 4 into 20 is 5, and distribute the 5. That's incorrect. All right, so because it's not 5 times 1, this is really 20 times 1. So you have to be careful. You have to distribute first. So we have 20 times 1/4, so that's 20 over 1. So 4 into 4 is 1, 4 into 20 is 5, so I get 5 here. All right, so 20 times 1/4 x is 5x, plus 20 times 1 is 20. So you see, if you had made a mistake and reduced first, you would have distributed a 5, and that would have been a 5, and that was incorrect. That's a 20. It's less than, and do the same thing here. You got to distribute first. So that's 20 over 1 times 2/5. So 5 into 5 is 1, 5 into 20 is 4, 4 times 2 is 8. So 20 times 2/5 x is 8x. And then 20 times 3 fifths, so notice all the work. 20 times 3 fifths. 5 and a 5 is 1. 5 and a 20 is 4. 4 times 3 is 12. So 20 times 3 fifths is 12. Okay. Now let's bring the variables to the left. So I'm going to subtract 8x. So notice I clear the fractions, the whole point. So I clear the fractions. I no longer have any fractions. So all my denominators are 1s. And specifically, they're all 1s. 5x over 1, 20 over 1, and so on. So it looks like all the other problems we've done. Okay, so when you have fractions, remember you want to multiply both sides by the LCD, just like you did when you had equations. So I'm going to subtract 8x from both sides, combine like terms. So 5x subtract 8x is a negative 3x plus 20 is less than, and then 8x minus 8x is 0. 0 plus 12 is 12. Using addition property inequality again, I'm going to subtract 20 from both sides. And then combine like terms, that's 0. So I get negative 3x is less than, and then that's 8. Negative 8, rather. 12 subtract 20 is a negative 8. And then, remember, I'm trying to get the variable x by itself. So I'm going to divide both sides by negative 3. Now remember, I'm dividing by negative 3. So I've got to reverse this inequality symbol. So negative 3 divided by negative 3 is 1. 1 times x is x. So my solutions will be any real number that is greater than, and remember, negative divided by negative is a positive. So it's greater than 8/3. So your graph, if this is 0, 1, 2, 3, remember 8/3, 8/3 is 2 2/3. That's 8/3. So remember, you use your calculator if you need to. 8 divided by 3 is 2.666 repeating. So remember, 0.66666 repeating is a fraction 2/3. If you didn't remember that, then remember, just use your calculator. Second, and then press P or B here. So you're changing this decimal to a fraction. In particular, really changing it to a mixed number. So that's 2 2/3. That's what this is. All right, so 2 2/3 is close to 3. So let's say it's right here. So I'm going to go ahead and leave it as an improper fraction, though. So that's 8/3. Since there's no equal sign, I'm going to use open circle. And I want to graph all the solutions, all the real numbers that are greater than 8/3. So to the right. So integral notation is say parentheses, 8/3, comma, infinity. And then if they ask you for set notation, you're going to say set of x's such that x is greater than 8/3. Okay, so that should help you with understanding how to solve linear inequalities. So that's going to be the end of this lesson.